Alright, starting lesson 2.3, we'll be working with long division. And we need to first write the dividend in descending order. Here's our dividend, and that is in descending order. Great. And insert placeholders with zero coefficients for missing powers. And in this case, we don't have any zero coefficients because there's no powers that are missing. Alright, so let's set up the long division. So you got x cubed plus 4x squared minus 3x minus 12. Okay, so first thing you need to ask yourself is x times what gives you x cubed? And that would be x squared. Alright, and we line up the powers. Okay, so we have x squared. X squared times x is x cubed. And then it's x squared times negative 3 is negative 3x squared. Alright, now the next thing you do is you subtract these. Now, as easy as long division is, I often see this mistake. Alright, so we're going to subtract. Now you just change the signs of all the terms here when you subtract. So that's going to be minus, and that's going to be plus. Alright, now if you originally started with a plus, I suggest that you scratch this out and just put a minus on top. Because I've seen students do this, where they just put like a dark minus there, and they still think it's a plus, and then that throws everything off. Alright, so just be careful with that. Alright, so the first terms cancel out. Then I'm left with 7x squared minus 3x. Bring it all down, the rest of it. Alright, now you're going to do, just like you started here before, you're going to start here now. Alright, so x times what gives you 7x squared? That would be 7x. Alright, so now we multiply, we get 7x squared. 7x times negative 3 is negative 21x. Alright, now we have to subtract. Alright, so I'm subtracting here, change that to a plus. Alright, now I get 18x minus 12. Alright, same deal as before. X times what gives you 18x? That would be 18. Okay, so we multiply 18 times x, and then 18 times negative 3, which is 54. And it's negative in this case, right? All right, now I subtract, so change the signs of everything, and I end up with 42 here. And that's all that I can do. All right, so what do we have now? What do we do with this information? Well, this represents my quotient, x squared plus 7x, the result I got after dividing. And then there's a remainder, so I just add that on, and the remainder goes over the divisor. This is what I was dividing by, that's my divisor. All right, and so this is my final solution. All right, quotient, remainder, divisor. On to the next example. Alright, use long division to verify that y sub 1 is equal to y sub 2. Alright, what do I have here? Alright, so it seems like division already took place in that expression. Alright, but here I could do some dividing. Alright, so I'm going to do, let's see how x plus 2 divides into x squared. Alright, but now there's a couple powers that have zero coefficients. So there's x to the first power, I have to include that. And then there's x to the 0th power, which is the constant, I have to include that. Alright, so now I have the right setup. So now I do x times what, x times what gives me x squared. That would be x. Line up the same powers. Alright, x times x is x squared, and I have x times 2 is 2x. Alright, now I subtract. Alright, here, watch out for this. I see a lot of students do this, but then they still end up adding. So just get rid of the whole sign, put subtraction on top. Alright, then we have negative 2x plus 0. Now, x times what gives you negative 2x? That would be negative 2. Oops, let's get rid of that circle. Negative 2. Alright, negative 2 times x is negative 2x. and then we have minus 4. All right, now change the signs. Plus, plus. Okay, so that cancels out, and I end up with 4. All right, so my end result here is that y sub 1 is equal to, all right, here's my quotient, plus my remainder over the divisor. All right, now is that the same as y sub 2? Yes, so they're both the same thing. Check, I verified that they're equal to each other. Going on to the next example. All right, synthetic division. All right, looks a little crazy by this example, but it's actually a very simple process. It only works with a divisor of the form x minus k, though. All right, so how exactly does it work? You have some polynomial, and then you have a divisor x minus k. All right, you simply set that equal to 0, and you solve for x. All right, and then you have your k here. And then all you have to do is first write out all the coefficients here. All right, and you bring down the first coefficient, and then you begin multiplication, k times a, that's all we have here, and then you add. All right, and then you get your new result here. All right, then you multiply k times whatever the result was, bring it up here, and then you add. Repeat that process until you get to the end here. If your remainder is 0, all right, that means that whatever you have here, that's actually a 0 or a solution for this polynomial. It's a root. All right, but we'll get to that down the road. All right, now use synthetic division to divide. Okay, so here we have x plus 2. Like I just set that equal to 0. And I get x equals negative 2. All right, and that's what we use in our synthetic division. Now I have my coefficients. Here's where a lot of students goof. So if I write out all the terms of the coefficient, there is one leading coefficient that's 0. And that's very important to include when doing your synthetic division. If you don't, you're going to get the wrong answer. Okay, so I have 5, 0, 6, and 8. Bring down the 5. Now I multiply. Negative 2 times 5 is negative 10. Then I add vertically. Then I multiply. Negative 2 times negative 10, 20. Then I add vertically. Then I multiply. Negative 2 times 26. Then I add vertically. Okay, so this is just like long division, but we have to know how to interpret what we're looking at here. This was essentially my divisor. This here is my quotient, and this is my remainder. Okay, how exactly do we set this up then? All right, my quotient, since you divided by x minus k, what was left over, your quotient, is going to have a degree, 1 less than the divisor or the dividend that you started with. So we're going to have 5x squared, squared minus 10x plus 26. Okay, then I have the remainder, so it's minus 44 over, what's the divisor? All right, let's put that back in the form it was in before we calculated the 0. That's x plus 2. All right, so be very careful with that. That's all there is to it. It's very simple once you get the hang of it. If you have any questions about this, please let me know. All right, one last thing. All right, now understanding everything in this example is very beneficial because it's going to show you why synthetic division can be so valuable. Okay, so we have this function here, and they tell you that these are factors to this function. All right, so this is where synthetic division comes into play. I'm going to use the value negative 2 and the value 1 with my synthetic division. All right, but you only use one at a time. Let's start off with negative 2, and then here I have all my leading coefficients, or not my leading coefficients, just my coefficients. All right, I'm going to bring down the 2, multiply, then add, multiply, then add, multiply, and then add. Okay, so I should get 0 at the end, right? Because it told me that these are factors here. And since they're factors, the remainder will always be 0. All right, now what do you do? Okay, so essentially what I've done here is if I factored this whole polynomial here, it would contain these, right? And since I used this 0 right now in this synthetic division, it canceled out the x plus 2 here. All right, leaving me with a polynomial that's left over, which is this. Okay, so what I'm going to do now is create another synthetic division using the leftover coefficients for the remaining polynomial. And then I'm going to use the other factor. Okay, because this factor now lies within this polynomial. All right, and what the synthetic division is going to do is cancel it out. So I bring down the 2. 1 times 2 is 2. Add them up, multiply, and then I get 0. Okay, so once again I should get 0 because they're telling me that this is a factor, and 0 will always be the remainder in that case. So now I have this leftover polynomial here, and if I write that out, I have my coefficients 2, and then I'm going to have x, and then minus 1. Okay, the last one should be your constant. And then you could just think of it as moving up with the powers as you go to the left. So then we have x to the 0, and then x to the 1. All right, don't need all that there though. All right, so this is what I have now. 2x minus 1 left over. But it asks, then state the function in factored form. Okay, well this was the remaining factor, and what were the factors I started with? X plus 2 and x minus 1. All right, so now I have the polynomial in factored form. And that's when synthetic division comes in to be very beneficial. Whenever they give you factors, you could find the remaining factors by using synthetic division against the polynomial. All right, now just so you understand this to finish off completely, if I were to multiply all this, it would give me this. All right, so that's the most important thing to understand at the end. All right, so we're done with the lesson now. If you have any questions, please make sure to ask. Begin the assignment at the bottom of the page.